Okay, so this is my video for quiz number 3 here. And in this problem we have a ball, and this red ball is connected to a pole and the ceiling by a rope. And the rope goes through an eye hook, and so we're given the angle between the pole and the ball and the angle between the ceiling and the ball. And we also know that the tension in both of those ropes will be the same because they're connected through that eye hook, and the problem also tells us that as well. And so the first thing I did is look at this problem, and it tells us it wants us to find the velocity of the ball as it goes around. And so I just listed out some of the things that we were given in the problem. And so we were given r, the distance of the ball to the pole from the center of the ball. We were given those two angles for our rope, and then we were told that the tension A equals tension B, and we were given the mass of that red ball. And so this is the free body diagram that I drew here. And looking at this, it was kind of confusing to keep the angles straight, and so I used a blue color there for angle number 1. And then by drawing the triangles, we could get the relationship there and put the angles down here as well to use when we're solving the problem. And then I set x as my positive direction to the right and y positive direction up. And then we have our weight, or mg, pulling the ball down. And then I set that equal to my kinetics diagram, which you can see here. And we know that the acceleration in a circle will point towards the center here, and so I drew that, and that's the only acceleration because it's not going up or down in this instant. And so to solve this problem, we needed to use our equation that we use a lot in this class, that force equals mass times acceleration. And so looking at the problem, I broke that down into components, and so I did force equals mass times acceleration in the y direction, and then again in the x direction. And so this is my equation for the y direction here. So we have our tension A going up plus our tension B going up times the sine of the given angle, the cosine of the given angle, and then our weight is pulling down. And that equals our mass times acceleration in the y, but we know that there's no acceleration in the y direction, and so we can set that equal to 0. And then looking at this equation that we've created, we can recognize that the only unknown here is our tension. We know both of the angles and the weight was given, and so what I did was take this equation and solve it for tension, and this is the equation here. And then just plugging in what was given in the problem, our angles and mass, and then plugging in gravity, we can solve to know what the tension in both of those wires is. So the tension is equal to 30.136. And then over here, I did the same thing in the x direction, and I set positive x going to the right. And so in the x direction, we don't have the weight pulling down. All we have is the tension of A times sine of that angle pulling to the left, so it's negative, and then minus the tension in B also pulling to the left times sine of that angle. And then we set that equal to our mass times acceleration going to the left towards the center of the circle. And then we know that we can replace this acceleration from our equations with this equation here, where acceleration equals v squared over rho, where v squared, v is what we're trying to find here, and rho is the radius given in the problem. And so I took this equation and I rearranged it, solving for our velocity. And so we have that velocity squared equals this equation here. The negatives cancel, and then plugging in what was given. So we found the tension in the first part. These angles were given, our given mass, and then our given radius, rho. And then plugging that in and taking the square root, we can find that the magnitude of the velocity, or the speed, is equal to 3.73 meters per second. And that was what the question wanted us to find. So that's all. Thank you.